Alrighty. This will take a little bit longer than normal because we have to talk about a whole bunch of stuff, but I also want to talk about taking notes and trying to teach you how to take notes. And the hardest thing is learning what to write down and what not to write down. And I think I talked about this a little bit yesterday, but if I didn't, we'll go from there. So, first slide. On this first slide, what do you think you should probably write down? The title of the section. Do you need to write down Geometry 492? No, because you know you're in Geometry 492. Do you need to write down Team Geo? No, because you don't even know what that means. And as we progress through these slides, that's going to be something we're going to talk about. What are you writing down? What do you think is relevant? Don't go into this thinking I'm going to pick little things out of every slideshow and quiz you on it. I'm not big about just memorizing things. I'm big on learning. Okay? So, first thing. This guy is named Rene Descartes. Anybody ever heard that name before? Really? Tell me about him. What do you know?
I only remember his name. I don't know anything.
You've just heard the name before. Anybody know anything else about him? French guy, because his name's Rene. He was a philosopher and a mathematician. He did two really important things that you should be aware of. One is more relevant than the other. The first one is, so when you draw a graph, on some graph paper, you call that a graph or a coordinate plane. The official name is called a Cartesian coordinate plane, and he invented that thing. See, Descartes, Cartesian, so he took part of his name and named the thing after himself. So he invented the Cartesian coordinate plane, also known as the graph. Okay. That's the important part. The other thing he did is he had a famous quote, and that quote is, "I think, therefore I am." How many people have heard that quote before? Good. If you want to impress people at the dinner table tonight, you can fire off the Latin "cogito ergo sum," which will probably just get you laughed off the dinner table, but still, it could be fun. So this is what he invented, this coordinate plane. This should all be reviewed, but I'm going to go through it just to make sure that we're all on the same page. All right, you got to watch or you'll miss this. What is that thing called? Did you see it? That thing.
X-axis.
Good. As we're doing this, also, if I call on you, first of all, I'll probably point at you, which is rude. I'm sorry, but I still don't know your names. And also start by telling me your name.
Mike.
Mike, what is it?
X-axis.
Okay, Mike, you want to get an A in the semester? If you can answer the following question without cheating, I'll give you an A for the semester. You can just kick back, sit in the back chair, sleep all the time. What's the fancy name for the x-axis? I wouldn't expect you to know that. I wouldn't expect anybody to know that. But you're right, that is the x-axis. Again, for the dinner table tonight, that's called the abscissa. Do you need to know that? No. Probably 3/4 of the math teachers that you talk to wouldn't know that. It's just one of those weird things that I decided to include just to give Mike a shot at an A for the semester. You want another shot at it, Mike?
Sure.
Attaboy. What's that thing called?
Y-axis.
Good. Do you know the fancy name for the y-axis? You got nothing to lose. Take a guess. This one's called the abscissa, so this would be called the...
The abscissa.
Sounds logical. It's actually called the ordinate. Okay, how about that little guy in the middle there? Name, please?
Isabella.
Isabella, what do you got for me?
Origin.
Beautiful. The origin. What's special about the origin, Isabella?
Zero.
0, 0. Very good. This one's a little hard to see, but it just popped up over there. Do you see that? What is that thing? Name, please?
A creeper.
Yeah.
It's a coordinate point.
The whole, say it again.
It's a point.
A point. Good. Also known as?
I.
Anybody else? It has coordinates, but that's not, we'll come back to that. Oh, back to you.
Coordinate pair.
Close, half right, 50%, not bad, still not passing, but doesn't destroy your self-esteem.
Megan and ordered pair.
Ordered pair. Nice job, Megan. Okay, Megan, bonus question. Why is it called an ordered pair? Shall we analyze the name?
Because the numbers are ordered.
Bingo. That's part of it. It's an ordered pair because they're ordered.
They're an ordered pair.
How many of them are there?
2.
There's 2, right? So it's pretty logical. XY is not the same thing as YX, so the order is important, and there's 2 of them, which makes a pair. We're doing good so far. That guy, we said that already. That guy is quadrant 1, which we refer to as I. Let's see how you do on pattern recognition. If this is quadrant 1, then this is quadrant.
4.
Oh, I couldn't fool you guys. I fooled third period. They all said 2. Right. This is 2. This is, or II. This is III, and this is IV. What's special about all the points in quadrant 1? Name
Or, and they have positive x and y.
Good. Positive x and y. What's special about all the points in quadrant 2?
They have negative.
Name.
Bella.
Bella.
They have negative x coordinates and then positive y coordinates.
Perfect. Staying with that. How about quadrant 3? Go.
You want name?
Yes. Yeah.
Okay, and then both negative x and y.
Good. And then quadrant 4.
Has some negative y, positive x.
Good. Okay. Is it safe to assume that you can all plot points? Anybody have trouble with that? You wouldn't admit to it even if you did, so I'll just move on. Okay. Now we get into some geometry. That was an algebra review, but we get into some geometry. We're going to start today with 3 terms, and we're going to call those undefined terms. They're undefined terms because we're not going to define them. We're going to talk about them, but they become terms, or you'll see that they're terms that are very hard to get a definition on. And there's a number of words that you use every day that fit into that category. If, for instance, I mentioned the word time, you all know what time is, right? Does anybody not? Good. Okay, so you all know what time is. But if you try to define the word time, that becomes a little trickier. Well, what is time? You can talk about things that time does. It makes the numbers change on the clock. It makes the hands go around on your watch. It makes you grow old, or it rots the fruit sitting on the counter, etc., etc. But getting an actual definition becomes pretty tricky. The same is true with the 3 terms that we're going to talk about here for geometry. So we're going to talk about them, describe them, pretty much beat them into the ground, but we won't have formal definitions. After we finish with these 3 terms, everything from that point on gets defined. And as I said yesterday, you're going to write all those definitions. Okay, so let's start with this guy. What is a point? So just for giggles, if you could all draw a point in your notes somewhere, I would really love that. You might already have one. Yeah, that's a good one. Yeah, you got one. Good. Uh-huh. Good. You guys are really good at points. I like it. Good. Don't really need to be checking that you know how to draw points, but keep walking around the room. Unfortunately, you're all wrong. Okay. So now we have to start talking about some weirdness. For instance, if we go back a couple slides, what was on that slide? The very first slide I showed you, not the title slide, the second one. What was on that slide? Rene Descartes. That is also incorrect. Rene Descartes was not on that slide.
Was a drawing of Rene Descartes?
Correct. It was a picture of Rene Descartes. Now that seems really stupid, but it's relevant to what we're doing here. What you drew in your notes is not a point by the terms that we're going to use to describe a point. What you drew is something we use to represent a point. Just like that picture was a representation of Rene Descartes, it wasn't really Rene Descartes. He's dead. Okay. So we're going to talk about points, but you're never going to be able to draw a point because our points are going to be described as being a location with no size and no shape. So how can it be there if it has no size? Well, it can't be. But it is. And this location thing is also bothersome. If it has no size, how can it have a location? It's the most specific location description possible. So if you're on the phone, well, you guys don't even talk on the phone. If you're texting your friends and they ask you where you are and you say at home, that's a pretty specific location. It narrows your neighborhood down to your house. However, in your house, there's a lot of different places you could be. You could be in the living room, the family room, the kitchen, the bathroom, your bedroom. And you can continue to make that more specific. You could be not only in your house, but in your bedroom. Well, where in your bedroom? Sitting at the desk, on your bed? Okay, on the bed. Where on the bed? At the pillow side or the foot side? Are you under the bed, on the bed, near the bed, whatever? That keeps getting more and more specific until it gets so small it has no size. Is that bothering people? I need an answer. Yes or no?
Yes.
It should be, because it doesn't make any sense. Because we're dealing with this thing called infinity. That's a symbol for infinity, by the way. And infinity doesn't really work well in the human mind, but we're going to try anyways. So we got this thing that's really, really, really tiny. How many of them would fit in this room? Too many. Can you be more specific? Somebody said it.
Ryan.
Ryan? Infinity. Good. Okay, Ryan, let's play with that a little bit. I got this cup sitting on my desk. How many points would fit in this cup?
Infinity.
Which one's bigger? This number of points or that number of points?
They're the same. Right?
Hold on, let me back up, make sure you understand the question. This whole room is filled with an infinite number of points. Does everybody agree? Infinity. The cup is filled with an infinite number of points. Everybody agree? You're saying that even though the cup's in the room, there's the same number of points in here as there are in the room.
Yes.
Are we okay with that?
Yes.
Yes? You agree with him? Comments?
But it depends on the size.
Oh, excellent statement. It does depend on the size. So let's not talk about points, let's talk about pennies. How many pennies would it take to fill this room?
A lot.
We'll go with a lot, I don't know an exact number. How many pennies would it take to fill the cup? Yeah, buck and a quarter. Which one has more pennies, the room or the cup? Okay, suppose we're talking about baby elephants. How many baby elephants fit in the room?
10.
10 maybe. How many fit in the cup? You have to take a chunk of a baby elephant, right? Which could get messy, but. So you're right, the size of that thing, whatever that thing is, pennies, baby elephants, matters. What about a point though? There's no size. So, how many fit in the room? How many fit in the cup? Which one's bigger?
Neither.
They're the same thing. Who's bothered by that? Again, you should be. That doesn't make any sense. More baby elephants in the room than in the cup. More pennies in the room than the cup. Now we talk about points and all the rules change, and that is true. Okay. So this isn't supposed to make a lot of sense because human brains aren't designed to process this kind of stuff. And we're going to get away from this weird theory stuff eventually, but we got to get there. We got to talk about it first to get us started. Okay, so where are we at now? We're at a pen that's not working.
There were.
Oh, there we go. Okay. So, a couple things to know about points. You see down here, I've drawn one, but that's not a point. Since we can't draw a point because your pencils aren't sharp enough, we need to come up with a way to represent a point, and we use one of those things which we call a dot. And realistically, after the first couple days, we're just going to call those points because we know what it means. Now, how do you denote a point or how do you name a point? You use a capital letter. And the capital letter is important because there's a big difference in this class between capitals and lowercase. Okay? That happens to be the point X. You can name it whatever letter you want. Okay, One last weird question about the point. Or a couple, actually. How many dimensions do you live in? 3, right? Length, width, and height. So there's theoretically 3 things you can measure. Like if you look at my desk, for instance. I can measure the width, the height, and the depth. Okay. How many dimensions does that point have? 2? Everybody agree? 2? No?
Dimension,
How many?
none.
None. Excellent. Good. We'll go with that. Was that a
That was a
act of
guess.
desperation?
That was a complete
Yeah,
guess.
0. It's 0 because there's nothing to measure. It has no size, so therefore you can't measure it, so it has no dimensions. Okay, now, we're done with all the weirdness. So to make it more palpable for your brain, we're going to start thinking of points as dots. So we got these dots. And I take a bunch of those dots and I start putting them in order. And I use more and more and more and more, and eventually I will get them all in a straight line, which leads us to our second undefined term, which is a line. So we start with a point, we put a bunch together, in other words, we stretch it, and we end up with a line. How long is a line? As long as you want it to be. And how long do we want it to be? Good, infinity. No thickness or width, just length, 1 dimension. Take 0 dimensions, stretch it, 1 dimension. We'll stretch that in a second and for the third term. We'll come back to that later. Here's how you name a line. There it is. Okay, so there's my line down at the bottom. There are an infinite number of points on that line, but 2 of those points are special to me. They're near and dear to my heart, so I gave them their own names. They are B and C. I'll come back to this M in a second. So since I named those 2 points, that gives me a method to name the line. And to name the line, I take 2 points on the line, the ones I named B and C, and I just put a little line symbol over it. Any 2 points. You don't like B and C? Put a different point on there. Let's say point Q. Then we could have the line BQ. Only 2 points though. You could have a bunch of named lines on there. You only need 2 to name it. And go ahead.
How come the symbol has arrows at the end if it's not visible to infinity?
Great question. Why are there arrowheads on the end of that? Name.
It represents the line going on forever.
The arrowheads show that it goes on forever.
No, I'm talking about above B, C, and BQ, because they don't go on forever.
This is just a way of naming the line. This is referring to a line passing through B and C, and the arrowheads show that it goes on forever. Okay. Is the line BC the same thing as the line CB? Yeah, it's the same thing. It's a line that goes through those 2 points. Sometimes, it doesn't happen very often, but sometimes we'll denote a line using a lowercase letter. In this case, M. So you could just call that line M. No symbol, just line M. We use this method a lot more frequently, though. Okay, so you can see how weird and complicated this whole system is going to become. Not only are we writing definitions, but then we also have to come up with notations to represent each of these things, because the bottom line is we're mathematicians, and mathematicians are lazy, and we don't like to write a lot of words out. We like to create symbols for everything. Okay. Took a 0-dimensional point, stretched it into a line with 1 dimension. Now if I take that line and stretch it in the other dimension, I end up with a what? Not horrible. And I just thought I'd put some dots on there for fun. Call that a plane. It doesn't have to have a grid on it, but it's the same idea. To keep your brain wrapped around this, think of a plane as a giant flat piece of paper that goes on forever and ever and ever. Okay. Big old flat surface. Which is made up of a whole bunch of points. And let's get right to a picture here. So here's my picture of the plane. Now that yellow thing that I drew up there represents a plane. What does it look like to you? A what? Trapezoid. Okay. I'm glad you mentioned that. There are certain words that you know that we're going to pretend you don't know. Trapezoid, parallelogram, square, triangle, rectangle. Those mean nothing to us until we get to a point where we can define them. So that's just a yellow thing that looks like a plane. Infinite number of points on it. I picked 3 of the points that were special. I gave them names A, B, and C, so that becomes the plane ABC. Or the plane CBA, or the plane BAC. If I don't want to write all that out, I could just call it, I could use a fancy script letter here and call that plane K. No symbol for plane, you have to just write out the word plane. We're not going to do a lot with this. The reason we don't do a lot with this is because it's assumed that all the work that we do is taking place on a plane. The plane of the smartboard, the plane of your paper, okay, the plane of the worksheet you're working on, et cetera, et cetera. Okay, we save all the 3D, most of the 3D stuff for second semester, so you don't have to worry about it that much. Okay, any questions on those 3 undefined terms? Everything that we do from this point on gets built with those 3 things. We've already done some building. We built lines from points. We built planes from lines. Later on, we'll build space from planes, but that's coming later. Now we get a couple definitions. Here's the first one. Collinear. Anybody know what that means? No? Okay, let's break it down then. Tell me your name. Jessica. You've had enough English, you know. What's the prefix co mean? Can I give you some examples? Coordinate, co-captains.
Oh, like, not, like extra or like secondary?
Not necessarily, because I think what you're describing is that one is higher than the other. If him and I are co-captains, who's more important?
Oh, wait,
Right.
there's just 2.
There's 2, right? So would it be okay if I use together? Right, okay, together. You cooperate, you work together. Co-captains, you share the captain's spot. What's linear mean? It's okay. What's it sound like? Good, you're done. Together, line. You with me? Okay, here we go. Then what's this mean? Beautiful. Collinear, together on the same line. Non-collinear, not on the same line. Sometimes you won't see the line. So if I pick somebody here like, please tell me your name.
Tom.
Tom. If I pick Tom, are Tom and I collinear?
Yes.
Yes. There's no, you can't see the line connecting us, but there would be a line that connects us. What if I move over here?
Yeah.
Yes. Yeah. Doesn't matter where I move? No. Okay, so him and I are collinear. You agree with me? Let's throw somebody else in the mix. Tell me your name, please. Adriana's in the back. Are Adriana and Tom collinear?
Yes.
Good. Are Adriana, Tom, and me collinear? No, there's no line that goes through all 3 of us. So 2 of them are always going to be collinear. You throw a 3rd person in, it could possibly screw it up. However, it doesn't have to, because all 6, I have trouble with numbers. All 6 of these people are collinear. Okay, so here we go with more pattern recognition. Collinear, together on the same line. Non-collinear, not together on the same line. Coplanar,
Together on the same plane.
together on the same plane, and also non-coplanar,
Not together.
not together on the same plane. It's a busy day. 3 undefined terms, 4 new definitions. Now we're going to draw some pictures. Okay, we good? Am I going too fast? Everybody caught up? Yeah, you're good. Slow down. 2 hours. No, you're fine. Okay, let's draw some pictures then. In your notes, sketch that scenario. Now notice it says the line XY is passing through the plane. It's not in the plane, it's passing through the plane. This is the hardest of the 3 examples I have for you to draw. Second one's real easy. This one's pretty tricky. So give it a shot, do the best you can, and then we'll take a look at it. They're your notes, so it's okay if you get it wrong. Nobody's going to grade you on your notes. Most common thing I'm seeing is this. Is that okay? Could be. It's a matter of perspective. Is that line in the plane or is that line passing through the plane? So if you want to try and visualize what's really going on here, think of taking your pencil and pushing it through a piece of paper so you get something like that. That's what we're trying to draw. Now, being able to draw that is a little trickier. And so maybe if you drew this, maybe that's what you meant. But there's some tricks that you can use, which I'll show you in the next slide to help you get to that. But before we do that, let's try the other problem. That one should be nice and easy. And remember, they're lines, so if they're lines, what do they need on them?
Arrows.
Arrowheads.
I had mine written.
It's not nearly as permanent as the real deal.
Yeah.
Number 2, easy? Okay. Number 3, we're not really going to do. I just want to talk about it a little bit. We'll cover something like number 3 later on when we're talking about Schoology and that kind of stuff. But plotting 3 points. Again, you told me that you're pretty confident in plotting points, and then connecting them with a straight edge shouldn't be that big of a deal. We'll get to that later. Okay, so notice what I did in problem number 1. A couple things going on there. That's not much different than the other one I drew, except I put that little dashed area in there. Why is that area dashed?
Because you're just looking through the plane.
Good. Yeah, it's hidden by the plane. So I want to show it's still back there. It didn't disappear, but it's hidden by the plane. Another quick term here. That point where a line meets a plane is called the foot. I have no idea why. I pretty much guarantee you all got number 2 correct. Right? Good. And then number 3 is that, what's that green thing called? No, we don't know that word yet. It's just a green thing. Okay, we're done. We can ignore that. So if you're done with your notes, you can put those away, pull out your iPads, and let's talk a little bit about some iPad action.